Especially for students who are perhaps designing their first infographic, there are many common issues, both in design and in data visualization, that you need to avoid. The biggest ones here are having paragraphs of information, a really unintuitive organization, or treating your icons negatively. Those sort of represent design issues. On the data side, oftentimes people fail to visualize data, they skew it, or they find really awkward ways to show it. The first design issue that is so common is having paragraphs. Students are so accustomed to communicating through papers and sort of in paragraph mode that when they get to an infographic, they sort of replicate that. Over here on this Eat Healthy infographic, you can see that they don't even have super long paragraphs, but they are primarily operating in a text mode. And that's really not what people expect or want from an infographic. Having unintuitive organization is another common issue on infographics. Remember that people are expecting to read these from top to bottom or left to right. So if you do have any sort of complexity in how to read this infographic, that is communicated really clearly to your audience and that you leverage design for that. Let's take a look at this infographic about whether or not under a certain law you can get a North Carolina's driver's permit. It's created by the North Carolina Justice Center in 2013. What you notice is probably that you don't really know where to start. The things that have visual weight here are likely these bold colors, red, orange, and green. That red is also sort of top and left. However, those are actually your endpoints. Where they want you to begin is in the black box over on the left. And that's really sort of a weird reading order to all of this. I mean, they help with these dashed lines, but they cross over themselves at certain points. It's really kind of hard to use this as a really intuitive way to get at this information and make a decision. Another very common design issue is that you are using icons, and for many infographics, you're using icons to represent people. And when you do that, when you are creating an icon as a stand-in for actual people, you can make a lot of bad choices that will end up casting them in a negative light. So say, for example, I want to visualize the statistic from the Anxiety and Depression Association of America that only 36.9% of people suffering from anxiety seek treatment. And for the purposes of this right now, I'm going to represent this as 3 out of 8. That's, I think, 37.5%, but we'll run with it. I could do this. Have 3 smiley faces and 5 frowny faces. However, especially given this topic, that can be incredibly offensive to people. We can reinforce this with things like our use of color. So here, if we are going to create sort of yellow, a happier smiley face color, and red, perhaps a more angry or negative color, we can just reinforce that we aren't recognizing that people are actually behind the statistic. Another thing that frequently happens, and I'm not really sure why, is that oftentimes people will create a bank of icons. They will literally cross out the others. Be very, very careful of this. Generally, never cross out a person. If you want to try to revise this, you might try making the people gray or making the inclusion group a different color. In terms of data visualizations themselves, one of the biggest problems is that students don't actually visualize their data. Oftentimes, this is a big numbers problem. Big numbers in quotation marks because it looks like this. Here is an infographic, actually from Easily, about Facebook facts. And look at the numbers. They are big numbers. And what I mean by that is instead of actually visualizing the data, they just found the numbers that they wanted to highlight and literally increased the font size. This is such a missed opportunity to actually visualize some of this data. For example, we could take that 1.31 billion and use an enumeration of icons, with each icon being 10 million. That clock at the very bottom, we're just using an icon of a clock. We could so easily shade in 18 minutes to reinforce that actual statistic. Another issue that often occurs with data is skewing it. One of the biggest perpetrators of this is 3D graphs, although scaling can skew as well. 3D charts and graphs are tilted on their axis, and as such are subject to something called volumetric distortion. the things at the front look bigger than the things at the back. If you look at this 3D graph, you probably think D is the largest, followed by B, and then C, and then A. But actually, D and B are the same. C is less than half the size of A. So 3D graphs and charts can really skew your data. Also, they tend to look a little bit cheesy. Another common thing on infographics is scaling to icons or shapes relative to each other to emphasize change. If I want to say at some point solar energy was this amount and then later it increased 3 times, and I am making this up, I don't actually have data. What I can do is I can scale up the now icon to 300% larger. However, since I'm scaling in 2 directions, this actually makes the icon 9 times larger in area. If you want to be really precise, you can do something like chart with a bar. However, most people are very accepting of scale distortions. This infographic from the CDC, for example, if you look at the soda, in the 1950s it was 7 ounces and now it's 42. The 42-ounce soda can contain more than 6 of the 7-ounce sodas. But they've done a few other things here, like include labels and specific values, so that you know with precision what those things are. The final sort of data visualization issue is sort of creating awkward and unnatural visualizations. What I mean by sort of a natural representation of things is that much data in a series sort of lends itself to one or a few different types of visualizations. If, for example, I wanted to talk about US GDP growth, 1970s, so we're going to 76 here, I could use a line chart with area shaded underneath, could just use a line, could use some bars with going up in time on the y-axis as we go from around 1 trillion to around 2 trillion. I shouldn't use a pie chart. That's wild. Many times students will, in attempt to get creative, try to use visualizations that don't really work for their data. You also want to make sure that you don't contravene expectations about charts, graphs, tables. If you do, you are going to end up misleading people. One really famous example of this is a Reuters graphic about gun deaths in Florida. Now, as you look at this, you might think, okay, there's a sort of a peak there around 2005, and then things tapered off. But look at it for another second, and look at the y-axis. It's inverted. At the very top is 0, making this a really misleading graph. In all things, make sure that your design and visualizations are helping your audience understand your content, your arguments, your main point. Make sure that whatever you give them is intuitive and readily accessible. Make sure that you don't mislead them, whether intentionally or unintentionally. When you do that, you are going to help your audience understand your argument, follow along with you so much better, and create a more effective infographic.